Hello classmates, let's learn this lesson, Low Frequency Electronic Circuits Chapter 5, Negative Feedback in Amplifier. Let's judge this RF's feedback polarity. Is it positive or negative feedback? So, its feedback type, what kind of feedback type? Let's judge. By definition, as the internal circuit is connected, on the output side, it extracted the entire voltage signal. The input side is parallel to the input, so it's a voltage parallel feedback. So it is positive feedback or negative feedback. Instantaneous polarity method. Signal through a basic amplifier, then judged by feedback network. The signal returns from this feedback network. Now we know that it is an electric current. That is, look at the flow of this current. If it is a current feedback, we want to determine the current direction on the feedback element. In order to be able to confirm this feedback element, is the input current of the basic amplifier weakened or enhanced? That is, if the current on this IF flows from left to right, that's what weakens the current of the basic amplifier. So, it's a negative feedback. Otherwise, it's a positive feedback. So take a look at instantaneous polarity method. If an instantaneous positive is given at the base. So now, let's use the instantaneous polarity method. If you give it an instantaneous positive at the base of the amplifier, its collector is an instantaneous negative. So if the RF side is instantaneously negative, so the current on the RF should flow from left to right. If the IF current flows from left to right, it weakens. Net input current input basic amplifier. Right. Previous input current was divided into two parts, divided by IF. So it's a negative feedback. It's a voltage parallel negative feedback. Okay, let's look at another topic. If the feedback element is RE, first, determine the polarity and the type of feedback. First of all, its feedback type needs to be identified. It is a current series. How do you determine the current feedback? As long as we don't extract the full voltage signal. It's just an electrical feedback. Its input side, two poles without a basic amplifier are in parallel. Conduct a current comparison. That's definitely a voltage comparison. So it's a current series feedback. What we care about is feedback network. This is its feedback voltage. Feedback voltage to net input voltage. This is the effect of the net input voltage of the basic amplifier. That is, the effect on VBE. Let's look at it using the instantaneous polarity method. If we first judge what is current series feedback, but you can also use short circuit. So, it's a current series method. So the instantaneous polarity method, I give the base an instantaneous positive. So this one, the emitter level is also an instantaneous positive. So the emitter level instantaneous positive and the base instantaneous positive. What impact does it have? We know net input signal VBE equals VI minus VE. So now VE is VF equals VI minus VF. VF has an instantaneous positive, so this VBE actually gets smaller. There's a tendency to get smaller. That is, the VBE is smaller than the previous initial input signal. So, it's a negative feedback. Instantaneous polarity on this feedback element does not mean it is positive or negative feedback. We only care about output signal from instantaneous polarity or feedback element. Output signal or feedback network is the net input signal weakened or enhanced. So now we have this inline feedback. What we are entering is a voltage signal. Let's see the VF pairs that are returned with feedback. Voltage input to basic amplifier, VBE. Is it weakened or enhanced? Because the input signal is VBVE. VE now has an upward trend, so VBE gets smaller. So the net input signal is smaller. The net input signal decreases. It is instantaneous. It's a negative feedback. So this current series negative feedback. Okay, let's practice with another question. Let's say this RF is a feedback element. I identified RS as feedback element. Judge its type of feedback. First, on the put inside, it is a parallel feedback. Output side, it is also on the output side. No complete output volt signal was extracted. So it's a current feedback. So it inputs current and outputs current. That's good. Let's judge by the instantaneous polarity method. Flow direction of current on RF. If the IF current flows from left to right, it's a negative feedback. If the IF current is judged by the instantaneous polarity method, it is right to left flow. It's a positive feedback. Let's have a look. If we give the first base instantaneous positive base of first tube, then follow the direction of the signal, is T1 connector instantaneously negative. So the base of the T2 tube is also transient negative. Right, the base of the T2 tube is also transient negative. The emitter of the T2 tube is also transient negative. If the emitter of T2 tube is instantaneously negative, instantaneous voltage drop, what we are concerned with is the flow of current on the feedback element. Because it's a parallel feedback, the flow direction of the current on this feedback element. If the right voltage drops instantaneously, so the current is going from left to right. From left to right, of course, reduce the current flowing into basic amplifier. So it's a negative feedback. This is a current shunt negative feedback. Take another look at the question. Let's have a look. If RF is not connected to the base of the T1 tube, instead, the emitter level connected to T1 tube, let's decide what type of feedback it has. Feedback type tweezers output unchanged. It's also a current feedback. The input end is a series feedback. Serial feedback, what we care about, is feedback point. The effect of voltage on net input voltage, right? Feedback point voltage we can tell from the instantaneous polarity. First, add an instantaneous positive to the base of the T1 tube. The collector of the T1 tube produces an instantaneous negative. An instantaneous negative at the base of a T2 tube. The emitter of a T2 tube is of course an instantaneous negative. Emitter instantaneous negative. It is also an instantaneous negative. That is, through the instantaneous polarity method, we can tell what this feedback element is feeding back. Point potential is an instantaneous drop. Since the net input signal equals VE, point E potential is now decreasing, so VBVE is going up. VBE is an increasing trend. Now my base gives me an instantaneous positive. Then what happened is that it leads to the entire basic amplifier. There's a tendency for the net input voltage to increase instantaneously. So it's a positive feedback. This circuit is a current series positive feedback. Look at this circuit. The output of this loop is a voltage. So it is a voltage. At this end, let's locate if AC short circuit. I just judge that this is a parallel connection. So this voltage is in parallel. The feedback is the current. Flow direction of current on the feedback element of our concern. That is instantaneous polarity. If the current direction on the RF can be judged, you know it's positive feedback and negative feedback. Let's have a look. If on the side of signal input, the signal that connects to the basic amplifier is actually its reverse input, I gave him an instantaneous positive word on the reverse input side. So it should be instantaneous at this output port negative, right? Reverse input is opposite to the output. It's instantaneously negative. If the output is instantaneous negative, what we care about is the current on the feedback element. The right potential of this resistance drops suddenly. So the current should flow from left to right. So the current on the RF is going from left to right. It's a negative feedback. Reduce the net input current of the input basic amplifier. Let's look at the force. Force, this is the voltage feedback, no problem. Then it returns now in parallel with the net input signal, but even here. So it doesn't compare this current. So it's a series feedback. The feedback is voltage, and that's what we are concerned about. Feedback network feedback back to this potential. The inverted VF change is produced by a change pair. Impact on net input signal. Let's look at the net input signal. It's to subtract the reverse input voltage from the same input. So the reverse input is this VF point potential. That's good. We give an instantaneous positive at the input port. The output port has an instantaneous positive. So after the resistance, the outer port to which the resistance is connected. It is also the instantaneous drop in voltage positive. Right, because your output is instantaneous positive, this is also instantaneous positive. So, because the net input signal equals the same direction input, subtract a reverse input terminal potential. The reverse input terminal potential is an increase. So the difference between them is a drop. The drop in their difference is certainly negative feedback. This is a voltage series negative feedback. Let's look at this topic. Its feedback type and polarity. We can tell that it doesn't extract the full voltage. This is an electric current. Output is current feedback. So if the feedback element is RF, so we said before, if connected to the input of this differential amplifier, the base words of the pipe for signal input, that's parallel. Otherwise, it is in series. So it's a series feedback. It connects to another. On the transistor that is not signal input. So it's a series feedback. This is a current series feedback. Is it positive or negative? We care about this instantaneous polarity method. That is, give it an instantaneous positive at the base of this T1 tube. So how does the signal go? First, to collector the T1 tube, it becomes instantaneous negative. So we are differential amplifier. Instantaneous positive on the side of the T1 tube. So instantaneous negative to the side of the T2 tube is an instantaneous positive. So it seems like saying instantaneous positive from base of T1 tube to collector of T2 tube. It is actually the base of the T1 tube to the T2 tube. The collector to the T1 pipe is instantaneous negative. But when it comes to T2 tweezers, the opposite is polarity. So it becomes instantaneous positive. Then the instantaneous positive of the T2 tube, does it go forward? The base of the T3 tube is also instantaneous positive. The emitter level of the T3 tube is also instantaneous positive because we are a series feedback. The concern is that the feedback element is coming back. The effect of this voltage signal on the basic input signal. So the feedback component that feeds back, the potential at this point on the left is also transient positive. So what is the net input signal? The net input signal is the base potential of T1 tube minus that of T2 tube. There's now instantaneous rise in the base potential of T2 tube. So the net input signal of the input differential amplifier, downward trend. So this is negative feedback. It's a common series negative feedback. Okay, let's look at this once again. Feedback element. From this point of view, it does not extract the full voltage because our output port has changed. Output port used to be above. Now I move down. So this is a current feedback. So on the input side, input I am the T1 tube connect to the signal. This is a split amplifier. the base of this pi connected to the signal. So it's a parallel connection. I am current parallel. Is the positive or negative feedback? Let's take a look. Instantaneous polarity method gives instantaneous positive on this T12 base. We follow the direction of the signal. Then the collector of the T12 is instantaneous negative. T32 base is also instantaneous negative. The T3 emitter is also transient negative. Now that we are in parallel, the flow direction of current on the feedback element is of concern. Now, this one of it. The emitter of this side twist, T32, is instantaneous negative. So, flow direction is left-right. It's weakening the net input signal, so it's a current parallel negative feedback. Take another question to learn. So it is secondary amplifier circuit consisting of a field effect too. Let's take a look at the feedback element. It's the RF IT extracts. This voltage is the entire output voltage. So it's a voltage feedback. So feedback back, it feeds back to this base. So it's also a parallel feedback. Let's see if it's positive or negative feedback. Using the instantaneous polarity method, the grid of the T12 gives him instantaneous positive words. By signal trend, it should drain to T12 should be instantaneous negative. Then the gate of the T22 is also transient negative. Then the drain of the T22 becomes instantaneous positive. Leakage instantaneous positive. What we care about is the current on the RF. So it has an instantaneous increase in the right potential. So the current is going from right to left. So what you care about is the net input signal on this device is bigger or smaller. Now, our net input signal, the connection on our side is current. It's the overlap of currents. So it's an increase in the current. It's a positive feedback. It's a voltage parallel positive feedback. Okay, let's look at this one below. So its feedback point has changed. Source pole of T12. T12 primary pole, so it is a voltage series. The effect of potential at this point of interest on net input signal. So the transient polarity method is the grid of the T12. Give it an instantaneous positive. Then the drain of the T12 is instantaneous negative. The grid of the T22 is instantaneous negative. The drain of the T22 is instantaneous positive. Leakage instantaneous positive. What we are concerned about is the effect of the potential on the left side of the RF. Because it is a series, what is a voltage comparison. So instantaneous positive after passing through the resistor is still instantaneous positive. So what about voltage XF that the T12 returns from this feedback? Here's the source of the T12. It's an instantaneous positive. What we are concerned about is the net input signal of the T12. This is the potential difference between the grid and the source. Then the resistor source difference VGS is equal to VG minus VS. VS rises, so VG minus VS is smaller. So weakening the net input signal is weakening. So it's a negative feedback. It's a voltage series negative feedback. Okay, this is example 5. We learned some basic concept of feedback amplifier circuits. It's closed loop gain, open loop gain feedback depth. So you know the type of feedback it has depending on how the output port and input port are connected. Voltage feedback, current feedback, and a series and parallel feedback. That because of feedback type, it determines what output signal is. What is the input signal? For example, voltage feedback, the output signal must be voltage. Current feedback input signal is current. So series feedback, the input signal is voltage. Parallel feedback input signal is current. So because of the type of feedback it has, we know what the input and output signals are. So that's what it is. For example, open loop gain. What is its net input signal? What is its output signal? The resulting if the voltage is in series. Its open gain is a comparison of voltage, so we use AV to represent it. So there are a lot of changes in the lower label. Voltage gain, current gain, a current in parallel. Its open loop gain should be a current gain. Let's say AI. So there's AI, AG, AR. When we are reading these lower corners, remember to distinguish clearly when you study. Don't confuse. So here's the table. Let's take a close look. There are also data written as follows. Written as follows for your reference only. Okay, this is the end of this class. Thank you.